Welcome to this episode of How Do We Pass Our Common Core Algebra Regents. So we're going to continue on question number 10, and it says the following. The heights, okay, and we're still dealing with statistics. We already saw how to construct a Box-and-Whisker plot. We saw dot plots. Now let's see what's going on. The height in inches of 12 students are listed below. So we have the height in here, okay? Which statement best describes the spread of this data? The spread, how spread out is. So the first one says the set of data is evenly spread. I have no idea. The median of the data is 59.5. The set of data is skewed because 59 is the only value below 60. 79 is an outlier which could affect the standard deviation of this data. All right, so all these, but we have median here, okay? It's dealing with median, it's dealing with spread, it's dealing with outliers. What is an outlier? Oh my God. Well, an outlier, let me get a piece of paper, let me see. How can I show you an outlier? Okay, let's have this piece of paper, right? Let's say we have the data. However you look at it, the best way I can see is an outlier. It's, let's say you have a Box-and-Whisker plot, just for the sake of doing it, right? And you have your minimum, you have your so-called fictitious maximum, but then there is a value. Like let's say you go numbers from like 20, 25, 26, 35, all the way to 40, right? 40 will be like, that's it. And then after that you have a value of 120. Whoa, 120. That doesn't really fit the data. It's all the way over there. So then this is what we will call an outlier. Now, of course, there is a formula that we could follow to see if there is an outlier, and I will show it to you. And I did actually write it when I was teaching you how to construct a Box-and-Whisker plot. So let's get to the problem. So what I'm gonna do is I'm gonna take the calculator, right? I'm gonna turn it on. See, it's not dead anymore. And I am going to quit that. So what I'm gonna do is the following. I am going to press stat, okay? The key that reads stat is your best friend, stat, and now enter with edit. And when I enter the data, okay? So this is not the data, so I'm gonna go up, right? I'm gonna press the clear key, and then I'm gonna go back down, and you see everything is erased. All right, cool then. So now let's input the data. So 61, 67, 72, 62, 65, enter, 59, enter, 60, enter, 79, enter, 60, enter, 61, enter, 64, enter, and 63. Okay. So right now I could tell you these values right here from 61, 72, and then from 72, see, they're all close to each other, but then there is this 79. Anyways, so let's see what's going on. So I'm gonna show you right now how to actually plot this data on the calculator. Ha! Becker learns everything. Caught you. Okay. So what I'm gonna do is I'm gonna calculate the statistics, right? So I'm gonna press stat and I'm gonna go and calculate. What do I want? One variable statistics. L1 is the only thing that you have in there. You don't have anything for frequency, and you're gonna calculate. So you have all that. So that will take care of one of the choices. Let me see, where is it? Right here, right? Yes. Okay. The median of this data is 59.5. The median is not 59.5, it's 62.5. See that? So that means that this is not the right choice. Remember what the question is. RTFQ, read the full question. Which statement best describes the spread? Which statement best describes? Okay. Now the set of data is evenly spread. Yeah, I could say that, yeah, the set of data might be, but this 79 really kills it. So anyway, so what we're gonna do is we are going to create, okay, a Box-and-Whisker plot. So second, oh, sorry. Okay, here. We're gonna go to second and then y equals. That is going to open up a menu of plots. So we're gonna actually press enter on plot number 1. Let's see. So I'm gonna tell you what to do so I can just focus on the screen. Oh, okay. Like that you can see better. All right, so on plot number 1, I'm gonna press enter and I'm gonna turn it on. Then I'm gonna go down and I'm gonna choose what is it that I want. I could look at the choices. I have I think it's a scatter plot, I have a line plot, I have a histogram, and I have one of my favorite things, the Box-and-Whisker Plot. Now this one, if you look at it, okay, you could see that it has like little dots to the right. What is that? Well, this choice will actually show you if there is something called an outlier, something that is out of the normal, okay? This one just gives you the whole thing. It will not show it to you. So let's do this one. Now I'm gonna press graph. Oh, look, wait. Frequent X list is L1. Frequency, it should be on 1, because what happens is that we're not gonna put L2 because we didn't put anything on L2. Frequency is 1 because you only have one of each. Got it? All right, mark this color. You could choose the color blue. It really doesn't matter. Now, let's actually graph it. So this is what we get. What in the world is this? Well, you know what? The windows, we need to set it up. We need to set up the windows. So our values, okay? Let's go and press window. Now, look at the values that we have. The values that we have go from 60 and go all the way to 79. So that's exactly what I'm gonna do. I'm gonna set my X minimum at let's say 59, which is closer, no, not 59, 55, which is closer to 60, right? And I'm gonna set my X maximum at 80 because I know that the maximum here is 79. Got it? Okay. Now for the X, for the Y, you could set, you see this negative 10 means that you're gonna see something going down. You could set it to 0 if you want to. The X maximum, since the maximum, the Y is the vertical thing, so the vertical axis, so you might want to set it at 2 if you want to. Really, frequency is only 1. Anyways, so now let's press the key that reads graph, and it's gonna give us a better picture of the Box-and-Whisker Plot. Look at this. Minimum, quartile number 1, quartile number 2, quartile number 3, maximum, fictitiously maximum, and this is the 79. Now, how do I know that? Well, press the key that reads trace, and now you see what it says. Okay, it tells you. Let me see now. Maybe I should put it over here. Okay, this is gonna be great. Okay, like that, you can see the values. Okay, so this one is 59, first quartile 60.3, second quartile, or the median, and third quartile, and then the maximum, okay, maximum 72. And look at when I go to the right again, it shows you the outlier and it shows you that it's 79. So we do have an outlier. Got it? Okay. And now the data is not really evenly spread. Look at this. The median goes like this, second quartile is skewed to the, you could say that most of the data happens on the right hand side, right? Because it's more spread on the right hand side, so it's skewed to the right. It's less spread on the right side. But anyways, that doesn't matter right now. What matters is that we have an outlier. So let's look at our choices and see what's going on. Okay. So the set of data is evenly spread? No, it's not evenly spread. So then, okay. The set of data is skewed because 59 is the only value below 60. It's not skewed. Listen, one value is not gonna make all the data being skewed. Skewed means like inclination either to the right or to the left. Okay? So no, this cannot be. 79 is an outlier, which would affect the standard deviation of this data. Definitely, an outlier will affect the standard deviation. So this one best describes the spread of the data. That 79 is an outlier. Now, let me give you the formula on how to find out if something is an outlier or not. So write it down. It's basically if you want to do this on top, right? Quartile number 3 plus 1.5 multiplied by the IQR. You already know what the IQR is. Let me see the IQR. Okay. So what is this? The interquartile range, okay? So they basically we will have 66, which is quartile number 3. Okay, just want to make sure I'm doing it right. Quartile number 3. Okay, plus 1.5. Okay, 1.5 of the interquartile range. What is the interquartile range? Well, let's see. Q3 is 66, correct? And quartile number 1 is 60.5. See that? That, my friends, will give you a total of 74.25. So, if the value, the next value was a 74.25 or less, then there are no outliers. Okay? That means that this point, if this point was a 74.25, then this would not be an outlier, and the Box-and-Whisker plot will show in its completion without no dots on the outside. But since we have a 79 in our data right here, okay, 79, and the maximum value that we can take for something not to be an outlier is 74.25, then that makes 79 an outlier, right? I hope you understood. If not, then just rewind it and you know, like, go over again. All right, so we got the answer to number 10. Let's go on to number 11. Jesus Christ, hopefully you could see better now. All right, right here. Okay, the 15 members of the French club sold candy bars to help fund their trip to Quebec. The table below shows the number of candy bars each member sold. So we have this. Now let's look at, in every multiple choice, it's also nice to just look at the choices. The mode is the best measure of central tendency. The mode, okay. The data have 2 outliers. Okay. Jesus Christ, let's look at this better. Okay, like that. The median is a 53. The range is 120. All right, so let's look at all these values. You already know how to calculate that. So we're going to input this data into our table. So what are we going to do? We're going to press stat and then edit, and we're going to go into L1, clear. And now let's start inputting the data from the table. Let's see, let me make this. Okay, you should be able to see it right there. All right, so let's put the data in there. Let me cover the marker, and you start inputting the data on your calculator, okay? So 0, sorry, 45, 68, 35, 50, 68, 38, 53, enter, 68, enter, 41, 53, 72, 43, 55, 120. Okay, and now we're going to calculate the statistics. So you already know what to do. You press stat, okay, go to the right, calculate one variable statistics. We put all the data in L1, nothing on the frequency, calculate. So this is it. So let's see what's true about some of the choices. All right, so let's see now. The median is 53. Let's see about the median. Yes, the median is 53 right here. Okay, so remember, RTFQ, which statement is false? The median is 53, so this is not false. So this is not the answer. The range is 120. Well, the range is from the maximum minus the minimum. What is the maximum? 120. And the minimum? 0. 120 minus 0 is 120. So yes, the range is 120. So this is not false. So now we have here 2 choices. The mode is the best measure of central tendency. I don't know about that. The data have 2 outliers. So you know what? Let's see if the data actually has 2 outliers. So what we're going to do is we could use this formula right here to figure out if they have the outliers, okay? Or we could just plot the points. So I am going to go and I'm going to press second y equals for the stat plot. And I want to get a Box-and-Whisker plot because that's the only, no, that's not the only thing I know, but that's basically what helps me. So you turn it on, we go down, and we choose the Box-and-Whisker plot that gives us the outliers. Not this one, but the previous one. Now we graph. We have a problem. I cannot see the whole thing. So What do? Well, go to the window and fix it. Okay, the minimum value is 0 and the maximum is 120. So we're talking about the horizontal axis. So the x minimum is going to be -1 because I want to see what's beyond the 0. And the maximum is going to be 123. That should be good, right? Okay then. Now let's graph this. There you go. Guess what do you see? One outlier here, one outlier here. So the data does have 2 outliers. So it's telling the truth, so this is not the answer. Now, number 1 is the answer. But why? Well, let's find what is the mode. Okay, the mode, the calculator does not give you the mode, so we have to figure it out. So 68, 68, 68. What other do we have? 53, 53. Okay, so basically the mode is 68. The mode is 68. From 0 to, remember this is an outlier, and 0 is also an outlier. So then I'm gonna actually start my data. My first quartile trace, okay, my first quartile starts at 41. And my minimum starts at 35, because that's what it says. Okay, and my third quartile is 68. So without excluding these 2 outliers, I can tell you that 68 is a bit too high to be the mode. I mean, no, it is the mode, but it's a bit too high for the data. If the mode was something like, I don't know, 40, then it would be a good measure of central tendency. But the mode is too high, so no, we don't take that. So this one right here is false. It's not the best measure of central tendency. Oh, okay. Let's go on to frequency tables. Oh my God, I forgot about this. All right, let's do it. I mean, it is what it is, right? So read the problem right here. Let me zoom out, because I'm not really gonna continue reading the problems every time. You read the problem. Okay, you read the problem, right? So let's see what's going on. So these are the number of students, okay, in each grade level who belong to one or more clubs. So what is the question? The question is, if there are 180 students in 9th grade, okay, 180 students in 9th grade, what percentage of the 9th grade students belong to more than one club? Oh, okay. So how do I do this? Okay, what percentage of the 9th grade belong to more than one club? So let's see. How many students? Okay, this is the 9th grade right here, okay? And more than one club means 2 or more, right? So we got 33 right here, and we got 12 right here. That's more than one club. So we have 33 plus 12 out of how many? Out of 180 students. So look, you create a ratio out of 180 students. All right then. So what is that? Well, what is 33 plus 12? That is 45. 45 out of possible 180 students. Okay then, so what is 45 divided by 180? Okay, let's see. 45 divided by 180, it's 0.25. This is 0.25. Now you want to turn a decimal into a percent, multiply by 100. You want to turn a percent into a decimal, divide by 100. So if I multiply this by 100, I'm basically moving this decimal point twice. So that's 25%. Now, are you going to just write this? No. You're going to write the following, okay? Based on the mathematical evidence, which is this, okay? 25% of the 9th grade students belong to more than one club. You need to rewrite it again, then pause it, rewind it, and listen to it again, okay? Based on the mathematical evidence provided, 25% of the ninth grade students belong to more than one club. Okay, let's move on to the next question. Did I do it? Yes. Okay, so the next question. My God, these things are long. Anyway, I hope you can see this. Read the question, okay? RTFQ. Oh, okay. So, based on this evidence, okay, so 60 students watch sports. 34 of these students did not like pop music. Of the students who did not watch sports, 70% like pop. Complete the two-way frequency table. All right, so let's see if we understand what's going on. 60 students watch sports. So watch sports. 60 students watch sports. Okay, what else do I know? 34 of these students, okay, did not like pop music. Don't like pop music. How many? 34. So what does that leave you over here? 26, because the total is 60, right? Okay, what else do I know? Well, of the students who did not watch sports, okay, 70% like pop music. So of the students who did not watch sports, well, how do I know how many students did not watch sports? Well, if you are RTFQ, you know that the survey was for 100 students. So if we got a total of 60 watching sports, we're gonna have a total of 40 not watching sports. Okay, and out of that, 70% like pop music. All right, so what is 70% of 40? Well, you use the calculator, right? All right, so 70% of 40 is 28. So then that's exactly what I'm gonna write. And now, if you have 70%, which is 28, like in pop thingy, I'm sorry, I thought I was talking to somebody. Then that means that we have 12 students here, okay, not like in pop, because that's 40, right? Oh, okay. So now what is the total here? Well, what do I have the total here? 54, right? What total do I have here? 46. And that makes a total of 100. Simple as that. Okay? My suggestion is that you watch this, how we did this problem, at least 3 times so you can get the hang of it. Right? So let's move on. Problem number 14, or the next question. I'm not gonna go by numbers. Alright, statistics class surveyed some students during one lunch period to obtain opinions about television programming preferences. The results of the surveys are summarized in the table below. Okay. Based on the sample, predict how many of the school's 351 males would prefer comedy. Justify your answer. This has to do with ratios. So let's see if I understood the question. Okay. Television programming preferences. Okay. So what do I know? Well, the question is, based on the sample, predict how many of the school's 351 males. Okay, so we're talking about males, not females, not total. Okay, this is very important. So what do I know about males and liking comedy? I know that 105, we have 105 males. And I know that 70 of those students like comedy. Okay. The question is how many of the 351 males in the school? let's do this two ways. First, we're gonna set up a proportion. So we have 70 students out of 105 liking comedy. So this proportion, if we're talking about the total population, we have 105 students here on the sample, so we have 351 on the total population. And they want to know how many students. Well, I don't know. That's what I'm gonna find out. So what we're gonna do is we're gonna cross multiply. Okay? So prepare to do this actually in 3 different ways. So I'm gonna multiply. So let's see now. 351 times 70 is 24,570. Okay? And now if I cross multiply here, I'm gonna get 105x. Now you know what, let's do the whole thing. Okay, I didn't want to do that because I already had 105 being divided over here, which is basically what I'm gonna have to do again. So we divide by 105 on both sides, and if we do that, we get 234. So x equals 234. All right, so enough of that. Let's do it in a different way. The other way you could do it is just find the percentage, okay, the projected percentage of the students, the sample students watching comedy or preferring comedy, sorry. So I have 70 over 105. That's what I had. So find out what that is. Okay, so 70 divided by 105 is 0.666666667, right? So that is your percentage. So we know that 60 let's just go like that, okay? So we know that 66 or 60, actually 67% of these guys prefer comedy. All right then. So what I have to find out is what is 67% of 351. So all I gotta do is multiply that percentage by 351. So times 351, and you get 234. So if I multiply the percentage by 351, I'm gonna get 234. All right. And now what was the last method? Okay. The last method, guys, I am going to show to you, but please don't be spreading the word around it because nobody knows how to do this, or at least not that I know in my school. Press, if you have this calculator or the TI-84 Plus C, press the key that reads math. Go all the way to the bottom, okay? But me, instead of going all the way to the bottom, okay? Oh, that's fine. So the bottom, see that? The bottom is numeric solver. Press enter. This, my friends, what you see here is an equation solver. So you have two sides of the equation. E1 means the left side, and then after the equal sign, you have E2, equation 2. So watch what I'm gonna do. I'm gonna press alpha y equals, enter, and I am going to write down the proportion that I wrote in here. So 70 over 105 is equal to x. Oops, I need a fraction, sorry. Alpha y equals, enter, equals to x over 351. And now you're gonna press graph if you have the TI-84 CE. Press, in other words, because it says solve. Okay. Now, if you only have the TI-84 Plus C, you're gonna have to press, after you press graph, you have to press alpha, enter. If not, you just press graph again. And voila, 234. You got it, right? Hopefully, this is one of the tricks that you can use to pass your Common Core Algebra Regions. Let's move on to the next problem. Oh my God. Okay, so here it says justify your answer. This is your justification, okay? you could say I set up a proportion in this way, blah, blah, blah. And once I solved the equation, I found out that X was 234. Or you could say, well, 67% of the sample watch comedy. Therefore, I multiply that by the total and I get what I need, 234. All right? All right, question number 15. Let's see now. Okay. Oh my God. Why are you so serious, Becca? Catch him. Okay, catch him. That's a new word in English. Catch him. All right. Public opinion polls. So we're dealing with public opinion now. And what does it say? It says, the poll was taken to explore the relationship between age and support for a candidate in an election. Okay, cool. Now question, what percent of the 21 to 40 age group, okay, was for the candidate? Okay, what percent of this group right here? So 4 is 30. Okay, so 30 students were for the candidate. But out of how many? Well, how many students do we have? Well, 30 plus 12 plus 8. So we have 30 out of possible what? Well, let's see. 12 plus 8. Oh my God, something really beat me. I think a bee beat me and I'm scratching my back. Ooh. All right, 30 plus 20 is 50. So this is 30 out of 50. 50. Let's go here. Second mode to get out of there. And 30 out of 50 is 0.6. 0.6 or 0.60. You want to turn this into a percentage, then you multiply by 100. 60. So 60% of the students were for the candidate for the election, whatever. All right. So, it was multiple choice. Dumb. Okay. Excuse me, que bruto. Okay. 15. We're done with that. Let's go with 16. What does it say about 16? I have no idea. So read RTFQ, right? Read the full question. So when we read the full question, a radio station did a survey to determine what kind of music to play by taking a sample of middle school, high school, okay, and college students. They were asked which of the 3 different types of music they prefer on the radio. Hip hop, alternative, or classic rock. The results are summarized in the table below. So you got the results. Anyway, what percent of the college students prefer classic rock? Oh God, what will I do? All right then. So please pause it, try to do it, and then we go over the answer. Got it? So remember, they prefer rock. So 14. We're talking about college students. Okay? So then, what do we get here? Okay, so we're going to get 14 out of something. So 16 plus 14 is 30. That's 50, right? I hope it's 50. And then what is 14 out of 50? Well, you are going to have to figure this out right now. I cannot do everything for you. So let's move on to the next problem. Okay. 17. Oh my God, I hate this. Why do I hate? Because I don't know if you're gonna be able to see it. Okay. Alright, so we're gonna talk about histograms. Histograms, oh my God, I hate this, but let's do this. A histogram. Where's a blank page? I don't have a blank page. Are you kidding me? No way. You're not. Please tell me you're not kidding me. Okay. I'll just use this page. A histogram, my friends, is nothing more than a Okay, this is the y-axis, the x-axis, or vertical, horizontal. In a histogram, if it starts at 0, you start right here. If it doesn't start at 0, you're gonna have to do something called a break. Okay, quick explanation. And then this bar tells you how many of each interval is happening. Okay, I will post another video explaining histograms, I guess. And then here, for example, if the interval is from 50 to 55, then this one will be 56 to 60, 61 to 65. They will have the same amount. You know what? I'm definitely posting a video on this. Alright, so the difference between a bar graph and a histogram is that in a histogram, the bars are together. Or you can have nothing in there. Alright? So now let's learn by having hands on the problem. Alright, so I got my data here. Okay, you have the problem, you read it. If you're my student, you have the handout, I hope. So let's see now. The heights in feet of former New York Knicks basketball players are listed below. Okay. The beauty part about this problem is that they actually provided you with the intervals. This is called the intervals, and this is the frequency. So what you're gonna do is like from 6.0 to 6.1. How many numbers are there? Well, is this between 6.0 and, let me zoom in, although, okay, yes, okay, like that, that series, you know how to do it. All right, 6.4, where does 6.4 fall into? It falls into 6.4 to 6.5, so I'm gonna cross it out, and I'm gonna put a tally over here, okay, 1. 6.9, where does it fall? It falls right here. So I'll put a tally here. Okay. 6.3, where does it fall? Right here. So I'm gonna cross it out and put a tally over here. 6.2 still falls under here, right? So 6.2, another tally. Okay, 6.3, another tally. Okay, and cross it out. 6.0 is over here. Okay, you get the hang of it, right? Okay then, so figure out how much frequency for each of these, okay? Take like a minute because I know you'll need it.
I didn't see anything. I didn't see anything.
I can hear you. Que bruto. Oh my god, sorry. This is supposed to be a number 2. It's supposed to be a number 3. Okay. So now you know. Oh, okay. So please have your table available. I am not going to waste time here. Now let us go into the graph. Let's see if we can actually, I'm gonna make it a little smaller. Hopefully you can still see it. Oh, okay. So I'm just gonna make marks on my axis. It would be nice if I could have a freaking ruler in here. I don't have a freaking ruler. Alright, Becker. You just messed up right here. So where am I gonna find? Wait, hold on a second. I'll go find a ruler somewhere in the world. The world. I'm gonna find a ruler. Wait, my bag. I have a ruler in my bag. Yes, sure. I have a ruler in my bag. And I do, of course, because I'm awesome. Cool. Am I awesome? Hello, people in the kitchen, am I awesome? Okay, I guess the dog is in the kitchen. Alright, so, yeah, I heard somebody laughing over there. Yeah. Alright, let me mark the axis, okay? Oh, okay. And now, The moment of truth. Learn by doing. So let's see what it says here on the question. Based on the frequency table created, draw and label a frequency histogram on the grid below. Sure. First of all, I gotta label my little histogram. Okay, so first of all, this is where you're gonna put the frequency. Oh, I can write backwards. I cannot. So frequency. This time I'm gonna have to write with the pencil because I don't think the marker is thin enough. So let's see now. Let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. My Spanish was kicking in. 16. How many intervals do we have? 1, 2, 3, 4, 5, 6. 16 divided by 6. Let's see. 16 divided by 6. 16 divided by 6 is 2.6. Alright, so we have our frequency table, which is right here, and now we are going to get ready to graph it. Okay, we're going to graph our frequency table. So we got the marks. We have 16 little things here, 16 units, and we have 1, 2, 3, 4, 5, 6 intervals. So 16 divided by 6 is not really 3, it's like 2 point something. So what I'm gonna do is I am going to create spacings of 2 marks. Okay, so it's gonna be 1, 2 and hash mark, 1, 2 hash mark. And you know what, let me do with the marker. Hash marks, 1, 2 hash mark, 1, 2 hash mark, 1, 2 hash mark, 1, 2 hash mark. I don't know how many have I done, but that's it. All right, now please remember these intervals are gonna go in between the hash marks. So I am going to turn the page over. Okay, you could see. So this is going to be from 6.0 to 6.1, 6.2 to 6.3. Let me change to the marker. 6.4 to 6.5, 6.6 to 6.7, 6.8 to 6.9. I know I'm blocking the next question, but I'll be able to answer it. And then from 7.0 to 7.1. And that was the last one. You see this? 7.0 to 7.1. So I did put my intervals right there because the intervals gotta go between the hash marks. Now let's start with the real test. Let's start graphing this thing. Well, let's see. 6.0 to 6.1. How many do I have? 3, right? What is the highest frequency here? The highest frequency is 11. You know what? Since the y-axis is the frequency, then I am going to create a scale. Well, actually, I don't have to create. Yeah, the scale is gonna go by ones. So let me see. Let me count how many do I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm gonna have to go by ones because this thing doesn't work. So I'm gonna go by ones. So watch this. 2, okay, this is 1, right? 2, 3, 4, 6, 8, 10, 11. That's the maximum. So this is 11 just in case. This is 10. This is 8, 6, 4, 2. So I went by ones, not by twos. Just remember that. Let me create my frequency table. So I have from 6.0 to 6.1, okay, I have 3 people with that height. I created my break, so I'm gonna start right here. 3 people, so I'm gonna go right here. Okay, that's 3 people right here. Beautiful, right? Okay, so now let us go into the next one. So from 6.2 to 6.3 we have 10 people. You see that? So I'm gonna go to 10, and the bars go together. See that? Okay. The next one. From 6.4 to 6.5, we have 11. So this is going to go just a little one more, right? You see that? And since I know that it's 2 units each, I already know where to stop. The next one, from 6.6 to 6.7, I have nothing. So guess what? This one is going to stay at 0. The bars will go together, but if you have 0, then sorry. Okay. 6.8 to 6.9, we have 2. 6.8 to 6.9, we have 2. And you should be looking at your table. So 2. Boom, boom, boom. Wow, without the ruler, it looks so ugly. And then from 7 to 7.1, we have 3. Remember? Boom, 3, right? Pum Tutankhamun, pum gorilla. Pum Tutankhamun, pum gorilla. And we got that. So basically that's the way it's supposed to look. Alright? So what are you gonna call the vert? This is what? What do you call this? This. I'm gonna call it the heights. Got it? Alright, so I hope you understood. In a histogram, the bars go together. And the frequency always goes in the y-axis. And whatever the intervals are, they go on the x-axis. In this case, the intervals were talking about height. Got it? Okay, let's move on to the next question. Number 18. Okay, right here. Good. Okay. So, pum, 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 gorilla, pum, Tutankhamun. Alright. Robin, not from Batman and Robin, right? So, Robin collected data on the number of hours she watched television on Sunday through Thursday night for a period of 3 weeks. She got really nothing to do, right? Anyways, that's not my concern. The data are shown in the table below. So this is the data. What do you want me to do? They want me to construct a box plot for the 15 values. So that's what I'm gonna do. And you know what to do, right? Sure. Call up on your favorite friend. Right here. So it says, using an appropriate scale on the number line below, construct a box plot for the 15 values. I already showed you how to construct a box plot, but you know what? Let's have some fun. So how do I do this? You press stat, you press enter. You clear whatever you have on the L1 thing, right? And let's deal with the numbers. Now, do these numbers have a frequency? No, it's just individual numbers. Week 1, week 2, week 3, Monday, Tuesday. These are not variables, okay? They do not account for variables. They do not change the outcome. So, or they're not multiplying the numbers. All right, so let's see now. So 4, right? 4.5, 4, 3, 5, 3, 3.5. Oh gosh, with decimals. Man, why do they have to put decimals in here? What's wrong with the people? Okay, 1, 2, 3. Oh, I'm nice. I know how to read. Okay, 2, 1.5, and 2.5. You see, I'm pointing out the numbers because I can get confused. All right. So this goes all in L1. I don't have no frequency table. So now let's calculate. So we press stats, okay? We're gonna calculate one variable statistics because we're only dealing with one variable. We put the data in L1, boom, boom, enter, and boom. Okay. So now, let's say this was not a multiple choice, which is really not. And let's say they ask you for justification. Look, your justification is the mathematical work that you just did. So let's start with this. Minimum is 1. Okay? So your minimum is 1. Your Q1 is 2. Q2, your median, is 3. Okay? Q3 is 4. Whoa, this is crazy. And your maximum is 5. Yo, this is gonna be easy. Okay, so I got all my data. I don't need the calculator anymore. And let me create a suitable scale. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hash marks. My minimum is 1, my maximum is 5, so I can make this 1, 2, 3, 4, 5. Okay, I'm not gonna go any more than that. So the median is 3. So I'm gonna go to 3. 1, 2, 3. Median. So that's the middle line of, well, not the middle line, but the line inside the box. You know what? Let me change the color. Let me go echo. So I'm gonna go to green. It doesn't look like green anymore. All right. So I just did quartile number 2. Now let me go to quartile number, I just did quartile number 2, which is 3. Okay. All right, now that we have the 5 summary, right, the 5 number summary, let us construct. So I need, let me see, the minimum. So 1, 2, 3, 4, 5. So the minimum is 1. So this is gonna be 1. Okay. And the scale I could go by 2s because, by 1s because it's not that much. So this is 2, this is 3, this is 4, this is 5. All right, and yeah, this is 6, whatever. All right, so I'm gonna grab the median first. The median is 3. So the median it goes all the way to 3. Now I'm gonna go down to quartile number 1, which is 2. So look. And now I'm gonna go to quartile number 3, which is 4. And now my minimum is 1. My maximum is 5. And my box plot or box and whisker plot is done. Got it? All right then, so I want to stop right here and we'll continue with how do we pass the Common Core Algebra Regents.